Good morning, learners. In this video, we are going to look at the analytical geometry questions from the November 2017 question paper 2. That is question 3 and 4 from this question paper. And let's start with that. So in this question here, it says, in the diagram, A, B, and C are points on the Cartesian plane. A, they don't give coordinates, but B is -6, -5. And C is 8, -4. Where is C? Oh, there is C. I thought there. A, B, C. C is 8, -4. The point F is 3, 3.5 there, and G are points on line AC such that AF is equal to FG. E is the x-intercept of AB. Alright, there we go. E is the x-intercept. Calculate the equation of AC in the form y is equal to mx plus c. So on AC, I have two coordinates that I can use to calculate the gradient. 3.1.1. The gradient of AC is going to be, I can use these two coordinates, 3, 3.5, which lies on the line. It's not A or C, it's F, but F lies on the same line, and C is the point 8, -4. So gradient of AC, difference in y, -4 minus, I would rather just write, instead of 3.5 maybe, just write this as an improper fraction. 3 times 2, which is 6, plus 1, 7 over 2. 7 over 2, difference in y over difference in x, 8 minus 3, just because typing improper fraction into a calculator is just a challenge. I prefer to just work with the improper fraction. Right, so I'm going to type there, my fraction is -4 minus another fraction, 7 over 2, and then that one 8 minus 3, and then this gives me -3 over 2, or -1.5, or -1.5, all of those accepted and fine. If you use 3.5 there in your calculator, in that place, don't use 3 and then fraction, or a fraction button, and in front of that a 3. Don't do this to type in 3.5. That's completely wrong. This is not 3.5. This is 3 over 2, which is 1.5, right? Because what the calculator does is it takes 3 times a half. If you type 3 and then next to that a fraction of half. So what you need to do is to type shift button with fractions, so that it gives you an option to put the 3 there and then the half, and then you'll see 3.5, not 3 over 2, but 7 over 2. Right, so I rather use the 7 over 2 just because it's a little bit less of a problem on the calculator. But if you use the mixed fraction, that's fine. Just use the mixed fraction button on the calculator as well. Okay, 3.1.2, the coordinates of G. The coordinates of G there, if the equation of BG is given as 7x minus 10y is equal to 8. Oh, I'm not done with 3.1.1. I'm busy trying to find the equation there of AC. I just worked out the gradient. So I also need to substitute then the gradient with any of these 2 points. Since that one has a fraction, I'm just going to work with this point. So into the line equation, let's work with this one. You can use either one, y is equal to mx plus c, or this one, both on your formula sheet. So y minus y1 is going to be -1, making that then a +4 is equal to m, which is -3 over 2, x minus x1, which is 8. And then I have y plus 4 is -3 over 2x. -3 over 2 times -8 is going to be positive 12, I think. I'm just going to double check. Negative 3 over 2 times negative 8 is positive 12. Okay, and then I want to jump that 4 over, so y is equal to negative 3 over 2 plus 12 minus 4, so plus 8. Okay, this is the equation of line AC. Now they say determine the coordinates of G if BG is given by 7x minus 10y. So G is the point of intersection between these two lines. They're giving me this line equation. I just calculated this one. So I'm just going to do simultaneous equations with y is equal to negative 3 over 2x plus 8. And the equation that they give to me here, 7x minus 10y, is equal to 8. Okay, simultaneous equations. I already have the y alone in this one. So I'm going to take that over to this side. 7x minus 10y, which is minus 3 over 2x plus 8 is equal to 8. Okay, and now I want to just simplify this. So I'm going to multiply the 10 in. Negative times negative is going to be positive. The negative 10 times negative 3 over 2 is going to be 15x. If you want to double check, 10 times 3 over 2 is 15x, and negative 10 times 8, negative 80, is equal to 8. So 7 plus 15, 22. And if I jump the 80 over, I have there 88, and x is then 88 divided by 22, which is 4. And if I substitute on this side, y is equal to negative 3 over 2x plus 8. You can somewhere use your calculator. Negative 3 over 2 times 4 plus 8. Let me just quickly, I did something weird now there, plus 8. I just quickly want to see if I can calculate this by head. It's 2. Yeah. Okay. It's 2. Right. So, that is the coordinates of G. Is x is 4, y is 2. Okay. 3.1.3, nope, 3.2. Okay, 3.2 says, now show by calculation that the coordinates of A is going to be 2, 5. Now, I have the coordinates of G. I know that this is the midpoint, so I'm just going to use midpoint formula to calculate that missing value A. So, F is the midpoint of AG. So, XA plus XG over 2 YA plus YG over 2. So the point F is given as 3, 3.5. I'm just going to rather write that again as 7 over 2. And I want to work out here now, but XG I just said is 4. And YG is 2. So this part is equal to that part. XA plus 4 over 2 is equal to 3. And this part here, YA plus 2 over 2 should be equal to 7 over 2. And then from there, I have two equations. One in terms of x, I can solve x. One in terms of y, I can solve y. So I'm going to just multiply the 2 on the other side. I have XA plus 4 is equal to 6. Take the 4 over, so XA is 6 minus 4, which is 2. And YA plus 2 is going to be 7 over 2 times 2, which is just 7. Subtract the 2 on the other side. So A is the point 2, 5, which is what they wanted me to show you. Alright, then Prove that EF is parallel to BG. Prove that EF is parallel to BG. Okay. I suppose the first thing I just want to explain to you quickly, the first thing I think to myself is, well, now I have the coordinates of A, which is 2, 5, right? And I have the coordinates of G, which is 4, 2. They want me to show that these two lines are parallel. So the first thing I think is, well, to have those two parallel, I want to show that the gradients are the same. Now this gradient I can quite easily get. This gradient, I'm going to need that point, which is the midpoint of those two. So I can get that point, then I get that gradient, then I get that gradient, and if they are equal, well, fine. But that seems like a lot of work. That will work, you can do that, but that seems like a lot of work for 4 marks. So I'm just thinking, is there maybe not another way? And then I see, oh, this looks like a triangle with the grade 12 Euclidean geometry, where those two are in the same ratio. So the midpoint theorem will, if I can show that that is also the midpoint, then this will be, E is the midpoint of that. I know F is the midpoint, so if E is the midpoint of that side, these lines will be parallel, obviously. So I'm going to quickly work out the midpoint of AB and see what I get. Right, so the midpoint of AB is going to be XA plus XB over 2 and YA plus YB over 2, which is then going to be 2 plus minus 6 it's negative 4 over 2, which is negative 2, and then 5 plus minus 5 is 0 over 2, so 0. And that means that E is negative 2, 0, since midpoint of AB also lies on the x-axis. Okay, since this is a 0, it makes the midpoint of AB on the x-axis. But E is the point on the x-axis. So E is the midpoint of AB, right? So E is the midpoint of AB is what I've basically shown here. And that means that EF is parallel to BG by converse of midpoint theorem. No, this is not converse of, this is just the midpoint theorem actually. The midpoint theorem says if a line connects the midpoints of two lines, it will be parallel to the third line and half the length. So this is the midpoint theorem. Right, alternatively, if you didn't notice to do this, let me just show you briefly what you could have done is you can calculate, well, the coordinates of E, which is you're going to do the same way. So you're going to calculate the coordinates of E. You can either use, but now you don't know necessarily that that is the midpoint. So maybe working the midpoint of that is not going to help you. You should calculate the equation of AB, right? By using gradient and then substitute the gradient with 1 point into, then you calculate the equation of this line. and then you make in the equation of this line the y value 0 to get the coordinates of E. And then if you have the coordinates of E, you're going to use gradient formula with those 2 points, and then separately you use gradient formula with those 2 points, and that shows that these two lines are parallel if the two gradients are the same. Right, that's a bit of a longer route than this though. Right, then question 3.4, ABCD is a parallelogram. ABC, and I'm guessing D is going to lie. ABCD should be a parallelogram like that, right? ABCD. So D is going to lie somewhere there, okay? With D in the first quadrant, yes. Calculate the coordinates of D. Now, typically, a parallelogram, the diagonals bisect one another, right? So what you can do, calculate the midpoint of AC, and then that midpoint should be the midpoint of BD, and you can get the coordinates from there. The first one, straightforward, the midpoint of AC. So you just substitute these 2 points and you actually get the midpoint. And then like the question earlier where we had the midpoint and you work out the missing side. So you're going to do that. What is easier though, I talked about this in one of the explanational videos in this series, is whatever happens from there to there is going to happen also from there to there. So I can see the x value moved from -6 to 8, moved 6 forward to 0 and another 8, so a total of 14 forward, right? I'm just going to write here the x value moved 14 forward and the y value went from -5 to -4, so 1 up, right? The same is going to happen to those 2 points. So from this x value 2, I'm going to move 14. From 2, move 14, it's going to be 16. And from 5, move 1 up, it's going to be 6. Okay, that's a very handy thing to know about parallelogram coordinates. So I can just write it down. It's 16, 6. If you want to explain there from B to C, it's XB plus 14 and YB plus 1. So from A to D, I'm going to have XA plus 14 and YA plus 1. Right. So if you want to explain that, where XA is going to be 2, so 2 plus 14 is the 16, and YA is 5, 5 plus 1 is the 6, is where I got this. If you just want to show some work, because this counts 4 marks, but well, I would accept that because you can actually do it like that. All right, then question 4 says, in the diagram, the point P, -4, 5, and the point K, -0, -3, are the endpoints of the diameter of a circle with a center at M. So this is given as a diameter. I suppose this is going to be a tangent. Let's just quickly look at that. S and R respectively the x and y intercept of the tangent, S and R the y intercept of the tangent. Since this is a tangent, that's a diameter, I know that these are perpendicular and mark it in. Theta is the inclination of PK, there it is, with the positive x-axis. Determine the gradient of SR. Okay, the gradient of SR. Well, the gradient of PK I can calculate, and then from that I can get perpendicular gradients quite easily. This is 4 marks. That is enough marks to do this amount of work. So the gradient of pk, I'm just going to calculate that first. P is the point -4, 5, and k is the point 0, -3. These are the coordinates of the endpoints of the diameter. So this is the gradient of the diameter, or the radius, that I'm calculating there. So difference in y, 5 minus -3, over difference in x, -4 minus 0. And this is 8 over -4, so -2. I'm just going to double check with my calculator quickly. 5 minus minus is +3 over -4 minus 0, so -2. Great. Okay, so then the gradient of SR, which they ask in this question, times the gradient of PK should be -1, because a tangent is perpendicular to a radius or a diameter, and perpendicular lines have the property that gradients multiply to be -1. So the gradient of SR is going to be -1 divided by -2, which is then positive half. Okay, so that's the gradient of SR. The next question, the equation of SR in the form y is equal to mx plus c. So, I have the gradient. There's a point that lies on the line P. So I have the gradient and a point that I can substitute into any one of the line equations. Y is equal to mx plus c is fine. So y5 is equal to m1/2 x, which is -4, plus c. And from this I can get my c value. Half of -4 is -2. And then jump the 2 over, so I have 7. C is 7. That means the equation of SR is going to be y is equal to m, which is a half, x plus 7. Okay. 4.1.3 says determine the equation of the circle in the form determine the equation of the circle in the form x minus a squared plus y minus b squared is equal to r squared. Now for this I need the AB, which is the coordinates of the center of the circle. The center of the circle in this case is just going to be the midpoint of P and K. So I can calculate that really quickly. And then is equal to r squared, the radius, which if I have that midpoint, I can just get the distance from there to there, or you can get the distance from there to there and just divide it by 2. Either way, you need the coordinates of the midpoint and you need the length of the radius to write the equation in this form. So let's get the coordinates of the midpoint M first. M is going to be the midpoint of PK, which I have there as well. So the x values added, which is -4 plus 0 over 2, and the y values added, 5 plus -3 over 2. And then this, you can use your calculator or your brain, is going to be -2, and 2 over 2 is 1. Okay, so that's the coordinates of the midpoint, and then you must get the length of the radius. So I have the length of the midpoint of the coordinates. I can just use that and this with the distance formula, but since I might have made a mistake there, it's actually more safe to use that and then half it. But just to save some time, I'm just going to go with MP, the length of the radius. MP is square root of, let me just write there, M is -2, 1, and P is -4, 5. So the length of MP is -2 minus, you take difference, minus -4, so that's going to be +4 squared, plus 1 minus 5 difference squared. If you need to check your formulas, guys, check the formulas so that you don't make mistakes. And don't show steps from here. Just type this into your calculator, because the steps, they don't count marks. You get a mark for the substitution, and then you get a mark for the answer. And now if you showed 5 steps and you made three mistakes along the way, then you're wasting time and you're opening up yourself for mistakes. So don't do that. 2 root 5, which I'm just going to leave in root form, since I'm not going to make this a decimal, 2 root 5, because I still need to put this in a formula where I have r squared. This is the radius, and if I square this, the square is going to be 1. So that means that the equation of my circle is x minus a, which I calculated as -2 and 1, the a and the b. So x minus -2 squared plus y minus 1 squared is equal to radius, which is 2 root 5. 2 root 5 squared, and then I can just simplify this a little bit by writing it as x plus 2 squared plus y minus 1 squared is equal to 2 squared is 4, and root 5 squared is 5. So 4 times 5, which is 20. And I'm going to leave it like that. Okay. The size of angle PKR is next. The size of angle PKR, that angle there, PKR, that angle there. Well, this is an exterior angle of the triangle there, and the exterior angle is equal to the opposite two interiors, which that there is 90, because the axes are always perpendicular to one another, and then PKR. So PKR plus that angle SOK should be theta. I can get theta quite easily. So let's start by getting theta. 4.1.4. Tan theta is equal to the gradient of PK, which I already calculated earlier. I don't need to do that again. The gradient of PK is -2. Alright, so tan theta is equal to -2. That means theta. And let me just show you what I do on my calculator. So if I type shift tan -2, it gives me -63.43, which obviously that angle size is not negative. That angle size there is not negative. It's measured from there as a 0, like how you measure on a cast diagram in that direction. So there is 90 plus then a little bit. So obviously 180 minus that 63, which I got here, is going to be, now since this is already -63, I'm just going to add 180, giving me then theta is 116,565. Which then 5,7. Okay, and then I know that theta should be equal to SOK plus angle PKR, which I need to calculate in this question. PKR, because of exterior angle of a triangle theorem, and then SOK is 90, because the axes are always perpendicular to one another. That means that PKR is equal to if I look at this, theta minus SOK, so theta minus SOK, which is 90. I still have theta on my calculator, so I'm just going to subtract 90 there, giving me 26.565, rounding it off to 26.57 degrees. Okay, that's question 4.1.4. We're nearly at the end. We have 4.1.5, 2 and 3 left. 4.1.5 says the equation of the tangent to the circle at K in the form y is equal to mx plus c. So since this one is perpendicular to that tangent and this line is also perpendicular to that tangent, these two lines are most definitely parallel and the gradients are the same. I already calculated the gradient of SR earlier as a half, I think. SR as a half. So, 4.1.5, the gradient of the tangent is going to be a half. And you can maybe also just state that a half times -2, which you know the gradient of the diameter should be -1, because still the gradient and the tangent is perpendicular. So the gradient of the tangent is a half going through the point K, 0, -3. On the sketch, I can use, well, either one of y is equal to mx plus c, or that y minus y1 is m times x minus x1 formula. Doesn't matter. Y is -3, m is a half, x is 0, plus c, which this becomes entirely 0, making c -3. So this equation is y is equal to m, which is a half x, plus c, which is -3. There's my line equation. Okay. Question 4.2 says, determine the values of t such that the line y is equal to half x plus t cuts the circle at two different points. Okay, now you see this is the same gradient, and values of t, I know that that line there is a half x plus, what was that equation? It was at 4.1.2, is y is equal to a half x plus 7, right? So I have SR, which is at y is equal to half x plus 7, right? And then I have the gradient, the tangent at K, which is given by y is equal to half x plus 5, right? No, -3. I don't know where I got that now, -3. Okay, and they now want to know, this is a bit of problem solving, but it's not an extremely difficult question. Determine the values of t such that the line cuts the circle at two different points. Now there, it cuts the circle at 1. If I move this line up by adding to the c value, if I move this line up, it's not going to cut the circle at all. If I move it down, it's always going to cut the circle at 2 points until I move it down to there where it cuts the circle 1 point, and then if I move it down further, obviously it's not going to cut the circle. So where it cuts the circle at two different points is between those lines. So the t must lie between those two values. T must lie between -3 and 7. Okay. Question 4.3. Calculate the area of triangle SMK. The area of SMK. Right. Okay. So the perpendicular height, if I use SM. Wait, I almost thought of that line. SMK. right? So the perpendicular height of this line, if I extend the base from the base, let me look at this as the base. Okay, so I'm going to look at this as my base of SMK. This is my base here. Then perpendicular to this line to the highest point is that. You see there, if I extend the base, that is the perpendicular height. So I need to find the length of PS and then the length of MK, which MK is just the radius, okay, which I have already. And I need to find the length of PS, although I don't have the coordinates of S. But S is where this line cuts the x-axis where y is 0, and I have that line equation, so I can get S. Okay. So what I want to do here with 4.3 is half base. I want to use MK as my base times the perpendicular height, and I want to use PS as the perpendicular height. Half MK times PS, right? Half base times perpendicular height. So I need MK and PS. MK is the radius of the circle, which is 4.1.3. I calculated the equation of the circle as 2 root 5 squared. The radius is 2 root 5, right? So MK is 2 root 5, it's the radius. PS, I'm going to need to work that out. So let's first get the coordinates of S. S is the x-intercept of the line SR, which SR I calculated as, where did I calculate the line SR there? Is y is equal to half x plus 7. So SR is y is equal to a half x plus 7, where S is my x-intercept, so I can make the y 0, half x plus 7. To get rid of the half, you can multiply by 2. Then you have this, meaning x is negative 14. That means S is the point negative 14, 0, and P is the point negative 4, 5, because I need the length of PS, right? I have MK, I need the length of PS. So distance formula PS is difference in x, negative 14 minus negative 4 squared, plus difference in y, 0 minus 5 squared, and this is negative 14 plus 4, which is negative 10. So I have negative 10 squared, and this is negative 5 plus negative 5 squared, which gives me 5 root 5. And since I still want to use this in my calculations, I'm not going to change it to a decimal now, meaning that the area is going to be half. I said most now earlier, the base is 2 root 5. 2 root 5 times 5 root 5. The half and the 2 will cancel. 5 root 5 times root 5. Well, you can use your calculator, but root 5 times root 5 is 5 times another 5 is going to be 25 squared units as the area. Alright, and that concludes the analytical questions from November 2017 paper. I hope you found this helpful. Keep on working hard during lockdown, and good luck with your exams whenever they are coming up. Good luck with lockdown. I hope you're staying safe.